Hey everybody, today we are going to talk about Newton's three laws of motion, and then we're going to go into how to take what we know from those laws of motion and how can we calculate force. So we're going to get into that here in just a second. But first, let's break down Newton's three laws. So what makes an object speed up, slow down, or change direction? Well, objects change their state of motion only when a net force is applied, and that is Newton's first law of motion. Objects change their state of motion only when a net force is applied. Now, objects want to maintain their state of motion. That means if an object is moving, it wants to keep moving. If an object is at rest, it wants to stay at rest. Um, so you've possibly heard this word before, inertia. Maybe you haven't, maybe you have. Inertia is the tendency of an object to resist change in motion unless an outside force acts on the object. So again, an object that's moving wants to keep moving, and an object that's sitting still wants to keep sitting still. Now, inertia is the tendency of an object to keep doing what it's doing, to resist change in motion. I like to use the example of picture riding along in a car, and maybe you have something hanging from the rearview mirror. If you turn left, that object hanging from the mirror turns right, like because it wants to stay where it was. Um, this example here, seat belts and car seats provide protection. Seat belts are literally using inertia. They're blocking inertia. When a car comes to a stop, your seatbelt and then the friction between you and the seatbelt provide an unbalanced backward force that's needed to bring you to a stop when the car stops. Think about it. Um, because of inertia, if you're moving, you want to keep moving. So when you're going down the highway at, let's say, 70 miles per hour, and what would happen if you had a head-on collision with another car going 70 miles per hour? If you did not have a seatbelt on, your body wants to continue going 70 miles per hour, and boom, you'd fly out the windshield, and that's bad news. So a seatbelt is literally an inertia blocker. It stops you. When the car stops, you stop. Um, but that's Newton's first law. Objects want to maintain their state of motion. An object at rest wants to stay at rest. An object in motion wants to stay in motion, unless some kind of a force changes that. Okay, Newton's second law, this is the law that gets into the mathematical part of calculating force, and we'll get into that shortly. But what determines how much an object speeds up or slows down? Well, a net force on an object is equal to mass times acceleration. So you take the object's mass and you take how quickly it can speed up or slow down, and you multiply those together, and that gives you the net force. So the unbalanced force on an object determines how much an object speeds up or slows down, and that's Newton's second law. So for Newton's second law, if you remember it's the math equation, you're good. Force equals mass times acceleration, or F equals m times a. The unit for force is newtons. You just put a capital N, it's newtons, just like kilograms for mass, or meters for distance, seconds for time. For force, it's newtons, so just a capital N. When you do the math problems, you'll label it with a capital N at the end of your problem. Now, for equal forces, a larger mass is going to accelerate less. Or you could say a smaller mass will accelerate more. If you look at these pictures here of the football players on the practice field, you have two guys pushing the equipment. So it's smaller mass. Over here, you have two guys pushing the equipment, but there's three guys standing on the other end. It has a larger mass. So out of the two guys are applying the same force, but the example on the right is going to accelerate less because there's more mass. So larger masses accelerate less, smaller masses accelerate more. For equal masses, a greater force produces a greater acceleration. If you look at these two examples, you have a girl driving her red Volkswagen Beetle And on the left picture, there's one guy pushing it. On the right picture, there's three people pushing it, the same guy plus two others. So the one with a greater force produces a greater acceleration. Or you could say the one with less force produces less acceleration. So in this example here, the picture on the right is going to accelerate more or have a greater acceleration. Or the picture on the left is going to have a smaller acceleration, however you want to look at it. And then let's look at Newton's third law of motion. In Newton's third law of motion, it says that for every action, there's an equal and opposite reaction. You have this picture here of a rocket ship. It's blasting off to the right because the propulsion is blasting off to the left. So that's an equal opposite reaction. Um, Same with a balloon. If you've ever blown up a balloon completely and you don't tie it and then you let go, the balloon flies off into the rest of the room or wherever you may be, because the force of the escaping air pressure going one direction pushes the balloon in the opposite direction. So again, these are examples of an equal and opposite reaction. Um, we also have this example. When you sit on a chair, your body exerts a downward force on the chair, which is happening because of gravity, and the chair exerts an upward force on the body. So it's pushing against your body, holding you up. There are two forces resulting from this interaction. There's a force on the chair and a force on your body. And when we have these two forces happening, these are called action and reaction forces. And again, they're completely equal and completely opposite. So they're the same amount of force going in the opposite direction. The same thing happens when you have birds flying through the air. This is an example of Newton's third law of motion, because as the birds push down on the air with their wings, the air pushes the wings up and then lift occurs. So a bird flies by use of its wings. The wings of a bird push air down, and in turn, the air reacts by pushing the bird up. So the size of the force on the air equals the size of the force on the bird, and the direction of the force in the air is equal and opposite the direction of the force on the bird. Again, this is an action-reaction force pair, and these action-reaction force pairs are what makes it possible for birds to fly. Okay? So that's basically Newton's three laws in a nutshell. Here we're going to shift gears a little bit, go back to Newton's second law, and we're going to look at how to calculate force based on what we know about Newton's laws. Okay, these are some examples of force practice problems. You can find this PDF document on Classroom, and this is actually your assignment. So if you're paying close attention, I'm going to do 2 or 3 examples from your exact assignment. So if you follow along, you can get those problems out of the way as well. What you're going to do is open the PDF. You're going to write these out on paper. When you're finished, take some pictures and paste them into the Google Doc. Okay. You're also welcome to use Kami and just annotate right on the PDF. But I feel like the pictures are easier if you can just write it out with paper. But again, you do whatever is easiest for you as long as you turn them in. But let's go through this. First, let's notice at the top, we see the formulas here. Force equals mass times acceleration. And when we do force, we take the mass they give us, the amount of acceleration they give us, multiply them together, and that gives us the force. Well, sometimes they give us the force and the acceleration, and we got to find the mass. So mass is going to equal force divided by acceleration. Sometimes they give us the force and the mass, and we got to find acceleration. And in this case, we take force divided by mass. So don't forget your units. If it's force, you label it with an N for newtons. If it's mass, you label it with a kg for kilograms. If it's acceleration, you label it with meters per second squared. But let's go ahead and go through some examples here. Let's look at number 1. It says calculate the force on an object that has a mass of 12 kilograms and an acceleration of 4 meters per second. Well, we can see right away it says calculate the force. So we're going to do F equals M times A. In this problem, our mass is 12 kilograms. and acceleration is 4 meters per second squared, okay? So F equals 12 kilograms times 4 meters per second squared. And if you multiply 12 times 4, you get 48. And again, newtons is how we label force. So right there, that's how you calculate the force. You take the mass times acceleration, and you label it with an N for newtons, okay? Well, let's skip down and look at question number 9, because this one is looking for something a little bit different here. This time they give us the force and they give us the mass, and we got to figure out acceleration. So let's look through that. A 3,000 Newton force is acted on an object with a 200 kilogram mass. So what is acceleration? Well, if we look at the equation on the front, it says acceleration equals force divided by mass. So A equals F over N, okay? So we figure out what our force is, what our mass is. In this case, our force is 3,000 newtons, and our mass is 200 kilograms, okay? So we line it all up here, plug it in. A equals 3,000 divided by 200. And when you figure out 3,000 divided by 200, it comes out to be 15. And again, it's acceleration, so it's meters per second squared, okay? That is how you find acceleration when you are given a force and a mass. Sometimes you're given a force and an acceleration, and you got to figure out mass. So let's do number 13 together as an example here. It says an object is moving with an acceleration of 55 meters per second squared at a force of 550 newtons. What is the object's mass? So it says, what is the object's mass? We know we're looking for mass. Mass equals force divided by acceleration, so F over A. We take these numbers here. Our force in this problem is 550 newtons. Our acceleration is 55 meters per second squared. Okay. Now we just plug them in. M equals 550 newtons divided by 55 meters per second squared. And when you take 550 divided by 55, that comes out to be 10. And we're doing mass, so it's 10 kilograms. Okay. So that is how you calculate force. That is how you find acceleration using force, and that is how you find mass using force. So what I want you guys to do now is to take this PDF with your problems and complete the remaining problems, including the ones that we did together. So there's some freebies for you. Get those turned in. And if you have any questions, please let me know. Good luck on your assignment.